Primordial holes, dark bombs. This intriguing question lies at the heart of a fascinating new theory. Could the universe's earliest, most mysterious objects be linked to cosmic explosions? We are on the cusp of potentially redefining our understanding of the cosmos. A groundbreaking theory proposed in November 2025 suggests a radical connection. It posits that certain unexplained cosmic explosions might be direct evidence of primordial black holes. These ancient entities, formed moments after the Big Bang, could be far more active than previously imagined. The theory speculates that these tiny, dense remnants of the early universe could be interacting with dark matter. Such interactions, if they occur, might trigger powerful, observable events across the cosmos. Imagine the universe as a canvas, occasionally illuminated by these sudden, intense flashes. Dark matter remains one of the universe's greatest puzzles. We know it exists due to its gravitational effects, but its composition eludes us. This new hypothesis offers a potential bridge between two cosmic mysteries: primordial black holes and dark matter. If these explosions are indeed linked to primordial black holes interacting with dark matter, it could revolutionize our understanding. It might provide the first direct observational evidence of dark matter's nature. The implications for cosmology would be profound. Are these cosmic fireworks a definitive clue to dark matter's origins? Or are they merely a fleeting flash in the pan of theoretical physics? Scientists are now actively exploring ways to test this audacious idea. The search for definitive proof continues, pushing the boundaries of astronomical observation and theoretical modeling. Each new discovery brings us closer to unraveling the universe's deepest secrets. The universe holds countless wonders, and perhaps some very old, very small, and very powerful secrets. Bombs ticking. Imagine the universe not as empty space, but as a vast, intricate network. This is the cosmic web, a colossal structure of galaxies and dark matter filaments. But what if this cosmic web, the very scaffolding of our universe, is being stretched and pulled apart by an unseen force? What if dark energy is not just expanding space, but actively distorting this grand design? The cosmic web is the largest known structure in the universe. It consists of vast filaments of dark matter and gas, connecting clusters of galaxies across billions of light years. Galaxies are born and evolve within this intricate network, flowing along its pathways. Understanding its dynamics is key to comprehending the universe's evolution. For decades, scientists have grappled with the mystery of dark energy. This enigmatic force is believed to be responsible for the accelerating expansion of the universe. It acts as a repulsive pressure, pushing galaxies further apart. However, its precise interaction with the cosmic web, especially at smaller scales, remains a subject of intense study. New simulations anticipated for release in November 2025 promise to shed light on this complex interplay. These advanced models aim to depict the cosmic web with unprecedented detail. Researchers are particularly interested in how dark energy influences the delicate filaments of the web. Are these structures merely expanding, or are they experiencing a more profound distortion? The outcome of these simulations could redefine our understanding of galaxy formation and evolution. If dark energy exerts a stronger, more localized pull on the filaments, it could alter the paths and mergers of galaxies. This could mean a different fate for galactic clusters, perhaps leading to more isolated systems or even accelerating their dispersal. The question remains: will the cosmic web maintain its delicate balance, or will it ultimately break under this immense invisible strain? Tensions rising. The dream of colonizing Mars is closer than ever to becoming a reality. But what if the very environment of the red planet poses an unseen danger to our minds? A chilling question emerges. Could Mars rays fog human brains by 2025? This isn't science fiction. It's a growing scientific concern. The journey to Mars and life on its surface expose astronauts to unprecedented levels of cosmic radiation. This radiation is far more intense than anything experienced on Earth. Recent scientific investigations are shedding light on a critical concern. New studies indicate a potential link between cosmic radiation, prevalent on Mars, and neurological decline. This radiation could significantly increase the risk of conditions like Alzheimer's disease. For future Martian colonists, this presents a profound challenge. The long-term effects of sustained radiation exposure are still being fully understood. Our journey to Mars might come with an unexpected cognitive cost. The imperative for robust shielding solutions has never been clearer. Engineers and scientists are racing to develop advanced materials and habitats. These innovations are crucial for safeguarding human health beyond Earth's protective atmosphere. Without adequate protection, the mental acuity of early Mars settlers could be compromised. This raises serious questions about the sustainability and success of long-duration missions. The choice becomes stark: shield our pioneers or accept the risks. So, what is the path forward for humanity's grand ambition? Do we push ahead, accepting the risks, or do we pause to perfect our defenses? The decision will shape the future of space exploration. The promise of Mars beckons, but the health of our pioneers must be paramount. The challenges are immense, yet the drive to explore remains, the fog's descending. For decades, our understanding of the universe has centered on its accelerating expansion. Galaxies are moving apart, and the cosmos grows ever larger. But what if this fundamental assumption is now being challenged? Imagine a scenario where this outward rush begins to falter. What if the universe's expansion is not only slowing down, but preparing for a dramatic reversal? This possibility is now sparking intense scientific discussion. The concept of a big crunch describes a universe that eventually stops expanding and begins to contract. All matter would then collapse back into an incredibly dense state. This theory offers a stark contrast to the widely accepted idea of an ever-expanding, cooling cosmos. Recent reports, including one highlighted in November 2025, suggest this might not be mere speculation. New data hints at a profound shift in cosmic dynamics. The universe's accelerated expansion is attributed to a mysterious force called dark energy. This enigmatic entity pushes space apart, counteracting gravity. However, emerging research indicates that dark energy's influence might be weakening. If dark energy's power diminishes, gravity would eventually regain dominance. This shift could fundamentally alter the universe's ultimate fate. It would mark a transition from an anticipated big rip to a big crunch. This potential weakening of dark energy presents a monumental challenge to current cosmological models. It ignites significant controversy and demands rigorous confirmation from the scientific community. The implications for our understanding of space and time are profound. Such a reversal would redefine our cosmic timeline and the very nature of existence. It forces us to reconsider everything we thought we knew about the universe's destiny. The idea of a decelerating universe leading to a big crunch is a startling prospect. It suggests a cyclical cosmos, perhaps one that has crunched and expanded before. The scientific journey to confirm or refute this theory is just beginning. The universe's ultimate fate remains one of the greatest mysteries, but the possibility of a cosmic crunch is now a compelling, if unsettling, consideration. Universe Bounces 2025 cycle. For centuries, humanity has pondered the ultimate fate of our cosmos. Is it a one-time event, expanding forever into cold oblivion, or something far more dynamic? Recent discussions have reignited interest in a fascinating alternative: the cyclical universe model. This theory suggests our universe might undergo an endless series of expansions and contractions. Imagine a universe that doesn't end in a big crunch collapse, but rather bounces back from a state of maximum expansion. This concept proposes an eternal rebirth, where each cycle sets the stage for the next. This model offers a compelling vision of cosmic perpetuity, avoiding the singularity of a big bang from nothing. It suggests a universe that has always existed, simply transforming through different phases. A specific article published on Medium in November 2025 brought renewed attention to these cyclic models. It explored the possibility of a universe that avoids a final collapse, instead entering a new expansion phase. This particular piece highlighted theoretical frameworks where the universe's expansion could reverse, not into a destructive crunch, but into a gentle bounce that initiates a new cosmic era. The core question remains: is our universe a grand repeating loop, or does it follow a linear path towards a definitive end? The cyclic model leans heavily towards the former, suggesting an infinite cosmic dance. This perspective challenges the conventional understanding of cosmic evolution. It opens up new avenues for theoretical physics and our understanding of time itself. The implications of a cyclical universe are profound. It suggests a universe constantly renewing itself, a perpetual motion machine on a cosmic scale. The idea of an eternal universe without a true beginning or end continues to captivate scientists and enthusiasts alike. Bounces happening. #space, #space success, #theory. For decades, scientists have grappled with a profound cosmic enigma. Galaxies spin far too quickly for their visible mass to hold them together. This discrepancy led to the pervasive theory of dark matter. This invisible substance, interacting only through gravity, is thought to make up about 27% of the universe. It's the unseen glue preventing galaxies from tearing themselves apart. But what if our understanding of gravity itself is incomplete? No dark matter. MOND saves galaxies. Enter modified Newtonian dynamics, or MOND. This theory proposes that gravity behaves differently at very low accelerations, such as those found in the outer regions of galaxies. Instead of adding invisible mass, MOND modifies the laws of gravity. Recent findings, highlighted in a November 2025 phys.org report, suggest MOND can accurately predict galactic rotation curves. It achieves this without invoking any hypothetical dark matter particles. This presents a compelling yet controversial alternative. The implications of MOND's success are immense. If modified gravity truly explains galactic dynamics, it would fundamentally alter our cosmological models. The search for dark matter particles, a cornerstone of modern physics, might become obsolete. However, MOND faces its own challenges. While it excels at explaining individual galaxies, its ability to account for larger cosmic structures, like galaxy clusters, is still debated. The scientific community remains divided on its ultimate validity: controversy or correct. The debate between dark matter and modified gravity continues to shape our understanding of the cosmos. Each new observation and theoretical refinement brings us closer to an answer. The universe, it seems, still holds many secrets. The curve's bending. Mars, our celestial neighbor, holds many secrets. One of the most perplexing is the continuous loss of its atmosphere. Imagine a planet slowly being stripped of its vital air. This phenomenon raises critical questions about Mars's past and future. Is the red planet's air truly bleeding away, stolen by an unseen force? A primary culprit behind this atmospheric erosion is the solar wind. This stream of charged particles constantly emanates from our sun. It relentlessly bombards Mars, which lacks a strong protective magnetic field. Unlike Earth, Mars cannot deflect these energetic particles effectively. Over billions of years, this solar assault has thinned its once thicker atmosphere. Scientists are keenly observing this process, especially with new data anticipated around October 2025. This upcoming information is expected to provide crucial insights into the current rate of atmospheric escape. It could reveal an accelerated rate of loss. This data will be pivotal for understanding the planet's long-term viability. It will help us gauge the true extent of the solar wind's impact. The challenge of rebuilding or even retaining Mars' atmosphere is immense. It requires overcoming fundamental planetary processes. Can humanity ever hope to reverse such a colossal natural phenomenon? The prospect of terraforming Mars hinges on solving this atmospheric dilemma. Without a stable atmosphere, any long-term human presence faces insurmountable obstacles. The question remains, does Mars hold hope for future habitation, or is it destined to remain a barren, airless world? The ongoing atmospheric bleed shapes its destiny. Our understanding of this process is critical for any future Martian endeavors. The data from 2025 will help us determine if Mars is a future home or merely a historical record of a lost atmosphere. The bleed's accelerating. Primordial holes burst, LIGO 2025. This bold prediction ignites the imagination of physicists and astronomers worldwide. These hypothetical objects, formed in the universe's earliest moments, could hold keys to some of cosmology's greatest mysteries. Unlike stellar black holes, primordial black holes are not born from collapsing stars. They are thought to have originated from density fluctuations in the very early universe, shortly after the Big Bang. Their existence remains theoretical, yet the implications of their discovery would be profound. They could represent a significant component of dark matter, the invisible substance dominating the cosmos. The Laser Interferometer Gravitational Wave Observatory, or LIGO, has revolutionized our understanding of the universe. It detects gravitational waves, ripples in space-time caused by cataclysmic cosmic events. In September 2025, LIGO is poised for a new era of observation. This advanced sensitivity could allow it to detect the subtle signatures of primordial black holes. Scientists anticipate that these ancient explosions could provide direct evidence of their existence. The search for these elusive objects is entering a critical phase. The theory of Hawking radiation suggests that black holes slowly evaporate over time, emitting particles. For very small primordial black holes, this evaporation could culminate in a final explosive burst of radiation. Detecting such a burst would be a monumental achievement. These ancient explosions could prove a direct link between primordial black holes and the elusive dark matter. If these bursts are observed, it would offer compelling evidence for a dark matter candidate that has long been theorized. It would reshape our understanding of cosmic composition. The potential detection of these Hawking bursts by LIGO in 2025 represents a pivotal moment. It could confirm a fundamental aspect of black hole physics and cosmology. This discovery would not merely be a scientific curiosity. It would be a paradigm shift, offering concrete answers to questions about the universe's earliest moments and its invisible constituents. The question remains, will these be cosmic fireworks or the final proof we seek? Bursts flashing. Mars ice, life hidden 2025? This question ignites the imagination of scientists and space enthusiasts alike. The possibility of discovering ancient life on the red planet is closer than ever before. NASA's Perseverance rover continues its groundbreaking mission on Mars. Since its landing, it has been meticulously exploring the Jezero crater, a site believed to have once held a vast lake. This ancient watery environment makes it a prime location for potential biosignatures. September 2025 marks a critical juncture for this endeavor. Scientists anticipate significant data analysis from samples collected by Perseverance. These samples, carefully sealed, are expected to contain clues about Mars's past habitability. The focus is on identifying biosignatures, which are indicators of past or present life. These could be organic molecules, specific mineral formations, or isotopic ratios. The presence of ancient water is a key prerequisite for such discoveries. The existence of ancient water bodies on Mars strongly suggests a potentially habitable past. If life ever arose on Mars, evidence of it would likely be preserved within these geological records. The rover's drilling operations target these very layers. The anticipation is immense, but so is the caution. Will the findings be a viral sensation confirming extraterrestrial life? or will they lead to further questions and research? The scientific community remains cautiously optimistic. Unlocking the secrets held within Martian ice could redefine our understanding of life in the universe. It could answer fundamental questions about our place in the cosmos. The implications of such a discovery are profound. The world watches as the data slowly makes its way back to Earth. Each piece of information brings us closer to an answer. The potential for a monumental discovery looms large. Ice is revealing. Imagine a universe where the greatest cosmic mystery simply vanishes. What if the invisible glue holding galaxies together, the elusive dark matter, was never there at all? A groundbreaking new theory suggests our understanding of galactic structure might be fundamentally flawed, but in a way that simplifies everything. From the University of Ottawa, a team of researchers has proposed a radical alternative. Their theory, unveiled in November 2025, posits that modified gravity alone can explain the observed rotation of galaxies. This approach eliminates the need for any hypothetical unseen particles. Instead, it suggests that gravity behaves differently on galactic scales than we currently understand. For decades, dark matter has been the prevailing explanation for discrepancies in galactic rotation curves. Without it, galaxies should theoretically fly apart. This new model, however, reinterprets these observations. It proposes that the gravitational force itself is altered, providing the necessary cohesion without any invisible stuff. If proven correct, this theory would represent a monumental shift in astrophysics. It would rewrite textbooks and fundamentally change our cosmic perspective. But is this a true revolution in our understanding of the universe, or merely an intriguing ruse? The scientific community is now poised to rigorously test these bold claims. The implications extend beyond just galactic dynamics. It could impact our models of the early universe, cosmic expansion, and even the fundamental laws of physics. The debate is just beginning, and the stakes couldn't be higher for our understanding of the cosmos. As the universe continues to reveal its secrets, the very equations we use to describe it are shifting. Dark energy changes. Could axions hold the key? For decades, scientists have grappled with the mysterious force accelerating the universe's expansion. This elusive energy makes up roughly 68% of our cosmos, yet its true nature remains one of the greatest puzzles in modern physics. The prevailing model suggests dark energy is a constant, unchanging force, often referred to as the cosmological constant. However, this model faces challenges when trying to perfectly align with all observational data regarding cosmic expansion. Discrepancies hint that our understanding might be incomplete. Recent research from the University of Chicago, anticipated for November 2025, proposes a groundbreaking alternative. This new theory suggests that dark energy might not be constant after all. Instead, it could be dynamic, evolving over cosmic time. The key to this evolving dark energy lies with hypothetical particles known as axions. These ultralight particles, if they exist, could interact with the fabric of space-time in ways that cause dark energy to vary. This variation could provide a more accurate fit for the observed expansion history of the universe. If dark energy is indeed dynamic, influenced by axions, it fundamentally alters our cosmological models. This shift could resolve long-standing tensions between different measurements of the universe's expansion rate. It moves us closer to a unified understanding of cosmic evolution. The question then becomes, is dark energy a static, immutable force, or is it a vibrant, changing component of our universe? This new axion-driven model offers a compelling argument for the latter. It opens up exciting avenues for future research and observation. Axions activating. For decades, dark energy has been understood as a constant, unchanging force driving the universe's expansion. It's the mysterious component making up roughly 68% of our cosmos. But what if this fundamental understanding is about to change? Imagine a universe where the very fabric of its expansion is not fixed. Dark energy fading, 2025 twist. This isn't science fiction. It's a potential new frontier in cosmology. Recent discussions, highlighted by reports like those on phys.org in November 2025, suggest a radical shift. The idea that dark energy might not be a constant, but rather a waning force, is gaining traction. This challenges decades of established cosmological models. If dark energy is indeed weakening, it fundamentally alters our predictions for the universe's ultimate fate. The implications are profound, reshaping our understanding of cosmic evolution. A diminishing dark energy would mean the universe's expansion might slow down or even reverse. This contrasts sharply with the prevailing Big Rip scenario, where constant dark energy accelerates expansion indefinitely. The cosmic fate hangs in the balance. This evolving force could lead to entirely different endgame scenarios for the cosmos. From a potential Big Crunch rebound to a more gradual, less violent end, the possibilities are vast. The question then becomes, will the universe eventually collapse back in on itself? A Big Crunch rebound? Or will it simply expand more slowly, leading to a different, perhaps less dramatic conclusion? Your take? The scientific community is actively exploring these possibilities, using new observational data and theoretical models. The universe's ultimate destiny hinges on this evolving force's weakening. Dark energy slowing, universe flip? For decades, we've understood our universe to be expanding at an ever-increasing rate. This acceleration was attributed to a mysterious, pervasive force known as dark energy. But what if that fundamental understanding is now changing? Recent findings suggest a dramatic shift in the cosmos, challenging long-held theories. A groundbreaking study reported in November 2025 has sent ripples through the scientific community. Researchers, including those cited by CNN, presented compelling evidence the universe's expansion might be decelerating. This directly challenges the prevailing model of an accelerating expansion. It raises profound questions about the ultimate fate of everything we know and observe. For years, the universe seemed destined for a big freeze, slowly expanding into cold, empty oblivion. Now, the possibility of a big crunch is back on the table. This scenario envisions the universe eventually collapsing back in on itself. Is this deceleration a sign of impending doom, or merely a new, unexpected chapter in cosmic destiny? The implications are staggering for our understanding of space and time. The speed of the universe's expansion is dropping. This isn't just a minor adjustment to a scientific model. It represents a potential paradigm shift in cosmology. The very fabric of reality might be behaving differently than we once thought. Scientists are now racing to understand the true nature of dark energy and the forces at play. The universe, it seems, still holds many profound secrets, constantly redefining our place within it.